Today we're going to be talking about ratios. A ratio is a comparison between two numbers. There are three ways that we compare the two numbers. We write ratios. The first is part to part. Those are both part of the whole, so part to part. The next we do is part to whole. And the third is whole to part. So there are a couple ways we can write these ratios. We can use them and write them in different forms. We can write them in words using the word to. We can write them using a colon, which is the dots. And we can write them using a bar. That's like a fraction bar, so we can write them on top of each other. Or we can write them one diagonal from the other. Remember, when we are doing ratios, order matters. Order is very important. It tells us which way. So, when we talk about part to part, a triangle to a square. We're going to use this image up here to talk about each of those. So, we're going to say we're comparing triangles to squares. There are 3 triangles, and there are 4 squares. So between those, we can write the words 2, so 3 2 4, or you can say 3:4, or you can do a fraction and do 3/4. All of those are parts. Triangles are a part of the shapes, and squares are a part of the shapes. So this is part to part. When we talk about squares to shapes, there are 4 squares and there are 7 shapes. So we can say 4 to 7, we can say 4:7, or we can say 4/7. All of these show 4 squares to the whole 7 shapes. So this is part to whole. Then when we talk about the triangles to shapes, we're not saying triangles to shapes, those. We're saying shapes to triangles. So there are 7 shapes to 3 triangles. That is why order matters, because 7 to 3 is different than saying 3 to 7. That would say there are 3 shapes for 7 triangles, and that's not true. So we say 7:3 or 7/3. All of this show whole to part. Ratios can be represented in 4 ways: fractions, decimals, percent, and differences. For the following 4 practices, we're going to use the example of 12 girls on the swim team and 24 boys on the swim team. So we're going to break that down so we know what we're talking about. We have 12 girls on the team. We have 24 boys on the team, which means we have 36, which means we have 36 total students on the team. So when we're talking about each of these, we have to talk about what they mean in context of this ratio. So if there are 12 girls on the team, they're part of the swim team. The 24 boys on the team are a part of the team, and the whole team is the 36 total swimmers. So we're going to use that in order to talk about each different representation. The first representation we're going to talk about is a fraction. For this fraction, they want to know the fraction of swim team is boys. So the swim team, we're going to make our fraction bar. The total swim team is actually the bottom because it's what fraction of the swim team. So the swim team would be the whole and is boys. and there are 24 boys. But because it's a fraction, we don't just leave it as 24 over 36. We're going to reduce it by dividing them both by 12. It's the biggest number that goes into both of them. And that leaves us with 2 over 3. We have to find, those are equivalent ratios. That 2/3 and 24 over 36 are equivalent ratios. And we're going to use those to say what that means. So for every 3 swimmers, 2 of them will be boys. So the second representation is a decimal. For the decimal question, they ask us what decimal of girls are on the swim team. So we have to say, we're still using 36 because that's the whole swim team, and we'll use 12 for girls. So to do a decimal, we have to do 12 divided by 36. Make our little house, put 12 on the inside and 36 on the outside. 36 will not go into 12, so we have to add our decimals. And then a 0. How many times does 36 go into 120? It goes in about 3 times. 3 times 6 is 18. Carry the 1. 3 times 3 is 9, plus 1 is 10. So we have 108. We subtract from that. We have to borrow and say 120 minus 8 is 12. Then bring down a 0. How many times does 36 go into 120? It still goes in at 3 times. 108 minus equals 12. So this is going to continue on forever and ever because this is a repeating decimal. So the decimal representation is 0.33, or 3 repeating swimmers are girls. The third way is percents. So to find a percent, you have to do the part divided by the whole, which will give you a decimal. Then you're going to have to multiply that by 100 to get your percent. The other way to think about that, instead of multiplying by 100, you can move the decimal 2 places to the right. So you're going to move the decimal 2 places to the right. And add the percent sign. Okay, so the example for this one, we're comparing what percent of boys are on the swim team. So if there are 24 divided by 36 boys, which gives us the decimal 0.6 repeating, and we want to turn that into a percent, we multiply it by 100, which just means that we move this decimal place 2 places to the right, and our resulting percent is 66%. Okay, so that tells us that 66% of the swim team is boys. The last way we can find, or we can represent ratios, is a difference. So they say, for this difference, how many more boys than girls are on the swim team? So if there are 24 boys and 12 girls, we say we're going to find the difference in the two, so we're going to subtract. How many more is a word that tells us to subtract. And we have 12 more boys than girls. So say there are 12 more boys than girls on the swim team. So, when we're looking at this last part we're looking at, so we've talked about fractions, decimals, and percents as part of the ways we can write ratios, but something we have to be able to do is convert fractions to decimals to percents. So we have this fun triangle to help us remember how to do it. To go from fractions to decimals, all we do is divide. To get from a fraction to a decimal, you gotta divide it. To get from a decimal to a percent, we're gonna multiply by 100 times by 100, or just move the decimal 2 places to the right. And to go from a percent to a fraction, you have to put the percent over 100 and simplify.